Once upon a time, life on Earth existed only in the seas. No footprints marked the land, and the idea of humanity was a distant dream in the grand story of life. From these humble beginnings, an extraordinary journey unfolded that placed us all where we are today. Evolution. From fossil records and genetic discoveries, scientists have pieced together a fascinating narrative about our distant past and changed our understanding of life itself. Keep watching to learn about the human story in our evolution from the dawn of time. The precursors of life. The human story begins with Earth's formation roughly 4.5 billion years ago. At the time, Earth was a harsh, uninhabitable planet, full of molten rock and raging storms, entirely different from the Earth we know and love today. But in this chaos, something incredible occurred: the birth of life. Around 3.5 billion years ago, simple single-celled organisms known as prokaryotes emerged in the oceans. They were the ancestors of all life on Earth, including humans. How do we know life evolved during this time? It seems nearly impossible to know anything about what our planet looked like more than 3.5 billion years ago. However, scientists can speculate on the timeline of evolution based on evidence of microscopic organisms or microbes that lived on rocks about 3.7 billion years ago. This evidence was a type of carbon molecule only produced by living things. More evidence was preserved in the hard structures or stromatolites that were sticky mats of microbes that trapped sediment and created layers. Inside the layers, minerals precipitate and form hard structures even after the microbes have died. Though rare, these stromatolite reefs still exist, and scientists have studied them to better understand the incredible beginning of life on Earth. The rise of eukaryotes. About 2 billion years ago, hundreds of millions of years after prokaryotes first emerged, they evolved into more complex structures, creating eukaryotes. These new organisms were cells with a nucleus and specialized compartments, allowing life to diversify and move one step closer to multicellular organisms. Unlike microbes, which don't have any complex organelles, eukaryotes have organelles to carry out distinct jobs inside the cells and nuclei to package their DNA and pass it on to future generations. Around this time, cells also began living together in groups. Larger groups of cells might be able to feed more efficiently or gain protection through their collective size. Living collectively in groups, cells started to support the group's needs, each cell performing a specific task. Some cells made junctions to hold the group together, while others made digestive enzymes that could break down food. It was a sort of rudimentary body composed of cells working together to make their group function more efficiently, almost like a society. One of this period's most remarkable life forms was cyanobacteria, which evolved about 2.4 billion years ago. It is remarkable because cyanobacteria are the world's first photosynthetic bacteria, making food using water and energy from the sun. This increased oxygen and made the environment less hospitable for other microbes, which could not tolerate oxygen. It also paved the way for life as we know it to evolve. Evidence of this great oxidation event can be seen in changes in seafloor rocks called banded iron formations. When shallow water enriched with oxygen mixes with deep iron-rich water, the iron creates a chemical reaction with the oxygen, oxidation, and forms minerals called iron oxide. Those minerals sank to the seafloor, forming dark layers in the rocks. The Cambrian explosion. Fast-forwarding to about 540 million years ago, after the prokaryotes and eukaryotes had been around for millions of years, the Cambrian explosion marked a dramatic increase in life's diversity. During this period, the ancestors of most modern animal groups appeared, and marine animals evolved most of the basic body forms that we observe in modern animals. We still have fossils from this period. Among many preserved animals, there are fossils of relatives of crustaceans, sponges, mollusks, worms, and algae. While there still weren't mammals, this period is when animals began to evolve beyond just cells. The Cambrian explosion paved the way for vertebrates, animals with spines, which is the lineage that would eventually lead to humans. During the Cambrian period, a shift occurred in the evolving animals. Over thousands of years, evolution favored more active animals with defined heads and tails for directional movement, which may have been used to hunt prey. Possibly because of this change, food webs began to emerge, forming the foundation for the ecosystems on Earth today. Although its impact on the rest of history is incredible, the term explosion for this period may be misleading. Cambrian life did not evolve in a quick explosion. It took millions of years, and many of the creatures that developed in this period began diverging during the Precambrian period. While the diversity in this period is remarkable, there are millions of years of evolution behind the scenes, resulting in these new kinds of animals. The age of dinosaurs and early mammals. While dinosaurs famously dominated the planet for millions of years, mammalian ancestors lived in their shadow, adapting to life as small nocturnal creatures. The first mammals evolved from members of a subclass of mammal-like reptiles called Synapsida during the late Triassic period, about 252 million to 201 million years ago. In general, they were small active carnivores. They also evolved something called heterodont dentition, meaning they had teeth separated into molars, incisors, and canines. That's something humans still have today. The extinction of the dinosaurs 65 million years ago opened the door for mammals to flourish and diversify. You may be wondering how mammalian ancestors, much smaller than the dinosaurs who once ruled our world, survived what many believe was one of the most violent events in Earth's history, the asteroid that wiped out the dinosaurs. They also faced the threat of extinction. Ecosystems collapsed, and the surface of the Earth endured vicious heat pulses and then a nuclear winter, during which average temperatures dropped by around 15 degrees Fahrenheit for 3 or 4 years. Although the mammals' most dangerous predators were gone, the world itself had become much more hazardous for the mammals. Luckily, they had something on their side that the dinosaurs didn't: their size. Because the mammals were so small, they could reproduce exponentially faster than bigger animals, replenishing their numbers even after many died in the disaster that wiped out the dinosaurs. Their size also allowed them to burrow into the ground, possibly protecting them from the asteroid and its consequences, and allowing the long story of human evolution to continue. The dawn of primates. The story of humanity begins in earnest with primates, including monkeys, apes, and eventually humans. Around 60 million years ago, the first primates evolved, developing traits like forward-facing eyes and grasping hands, all adaptations that helped them thrive in tree-dwelling environments. About 6 million years ago, a population of primates split into 2 lineages. One branch led to modern chimpanzees, our closest living relatives, while the other gave rise to the earliest human ancestors, known as hominins. This split marked the beginning of our evolutionary journey and the beginning of a much more complex story. Scientists still don't know all the details of human evolution or how the many members of the genus Homo may have interacted or reproduced to create humans as we know them today. The Australopithecines. Australopithecines, such as the famous fossilized skeleton of a hominin named Lucy, lived between 2 and 4 million years ago. They were a collection of early hominins that walked upright. This adaptation freed their hands for tools and other tasks, setting the stage for further developments that would set them apart from other mammals. They are also the closest known relatives of our genus, Homo. Though we don't fully understand how they play into our evolutionary story, they resemble some of the earliest humans. They stood fully upright, with their skull positioned directly over their spine, and had teeth similar to apes. The person who discovered the first Australopithecine fossil described them as an intermediate between anthropoids and man. The rise of Homo and the emergence of Homo sapiens. Around 2 million years ago, the first member of the genus Homo emerged. Homo habilis, known as the handyman, was one of the first species to use tools. Although there is some evidence of stone tools slightly older than the oldest evidence of Homo habilis, they have been thought to be the first maker of stone tools. Though they had a smaller face and teeth than in older hominin species, they retained some ape-like features, including long arms and a prognathic face, meaning the jaw protruded beyond the rest of the face. There is another species called Homo rudolfensis that may have coexisted or been the first example of the genus Homo. Still, Homo habilis is widely regarded as the first. Homo erectus, a later species of human and potentially one of the most significant, expanded out of Africa. They developed advanced tools, may have controlled fire for the first time in history, and adapted to diverse environments. They were also the first hominids to resemble modern humans anatomically. They stood upright and began to resemble apes less, with shorter arms, a smaller forehead, and a wider nose, jaws, and palate. Two of our closest evolutionary cousins, the Neanderthals and the Denisovans, emerged around 400,000 years ago. Neanderthals thrived in Europe and Western Asia, while the Denisovans inhabited parts of Asia. These groups interbred with early Homo sapiens, leaving traces of their DNA in modern humans. While we know much about the Neanderthals, the Denisovans are more mysterious. They left behind traces of DNA, but only a few tooth and bone remains have been discovered so far. Homo sapiens, our species, first appeared in Africa around 300,000 years ago. We developed larger brains, complex languages, and advanced tools. Around 70,000 years ago, Homo sapiens began migrating out of Africa, spreading across the globe and adapting to diverse environments. This period, known as the Great Migration, marked the beginning of our dominance as a species. The Agricultural Revolution. The invention of agriculture transformed human societies. Around 10,000 years ago, humans shifted from a hunter-gatherer lifestyle and began cultivating crops and domesticating animals, leading to permanent settlements and the rise of civilizations. This era set the stage for technological advancements and societal complexities that define modern humanity, allowing early humans to change from a hunting and gathering people to one of agriculture and animal domestication. This agricultural revolution is one of the last steps in the evolution of humans as we know them today. This shift created genetic adaptations related to diet, disease resistance, and population growth. It also marked the start of selective evolution as we began to domesticate animals and breed them for our purposes. The increased food supply allowed a dramatic increase in the human population. Although we have evolved since then, most of our evolution has been in genes related to height, skin pigmentation, and susceptibility to certain diseases. The modern era. Today, humanity continues to evolve biologically, culturally, and technologically. While we can't see biological evolution clearly in just one lifetime, we can see our advances in culture and technology. From the discovery of DNA to the development of artificial intelligence, our species is shaping the future in unprecedented ways. Evolution is constantly happening in every species, including humans. While we can't see it without the perspective of millions of years, our species is changing, and the animals of our world may look entirely different someday. The story of human evolution is far from over. How would you like to get a deeper understanding of history, impress your friends, and predict the future more accurately based on past events? If this sounds like something you might be into, then check out the brand new Captivating History Book Club by clicking the first link in the description. To learn more about evolution and its history, check out our book, Evolutionary History, a captivating guide to the theory of evolution, evolutionary history, and human evolution. It's available as an ebook, paperback, and audiobook. If you found the video captivating, please hit the like button and subscribe for more videos like this.